I'm Erin Kowalski out of the Grand Junction field office for the BLM. I'm a rangeland management specialist and I have a really strong background in ecology. So the Pine Gulch Fire is here in western Colorado. We're considered high desert. The town of Grand Junction is 4,600 feet, and I think the fire was pretty close to that, maybe 5,000 feet. And then it started in the lower PJ saltbrush communities, and by the end had gone all the way up into like aspen type community. So a lot of dry in the desert, and then we even had a little bit more of the mountain type ecosystem, but it was also dry as well, so it burned really quickly. When it was all said and done, the fire burned 138,000 acres, which is about a tenth of our field office here in Grand Junction. And at the time, they were boasting that it was the largest Colorado fire in history. And I think we had that record for 48 days before Cameron Creek blew that out of the water, and it grew to over 200,000 acres. I think for Colorado, this was a huge year. We had never seen that much fire activity, and resources were really spread thin. So, as a resource advisor, we're out there working alongside the firefighters, and the ultimate goal is safety. And so we come in with the resources in mind, but ultimately safety of personnel and structures is the primary goal. So having that in mind, putting bulldozer line in is a great way to make a fire break. Bulldozers are used a lot to help with fire suppression on really big fires. And a lot of times they back burn off of it. And when they put in the dozer line, every office is different, whether it's Forest Service or BLM or Park Service. But our field office, if it was along a pre-existing route, that was usually a pretty safe bet that it may have been cleared for cultural stuff before, and we might already know some of the sensitive plant populations. The fire did burn up into sage grouse territory up on top, just a little bit of it. So that was another big concern, is sage grouse. So for guiding the dozer line, we would look at some of the information that we already had and try to guide them to avoid plants or animals or sage grouse leks.
Hello, my name's Marlon. I'm the Monitoring and Weeds Coordinator for the Grand Junction BLM office here, and this is one of the areas that they did a backburn on. As you guys saw walking in, they kind of dozed a line in and out of this riparian area all the way down to Munger Creek, just to make sure that the backburn didn't bleed onto the highway. Originally it was a big sagebrush flat here, and it was just mostly like cheatgrass and annual wheat and crested wheat kind of grasses. And so for us, one of our main concerns was the riparian areas and protecting the cottonwoods from the backburn. Even though we did have to doze into some of the riparian areas, I still think we did a good job of keeping it mostly on the other side and keeping those unburned.
Hi, my name is Kevin Hyatt. I'm a hydrologist with the Grand Junction Field Office BLM. My job as a hydrologist and on the fires, as a resource specialist, and then I did help assist in the burned area emergency response, or BAER, effort after the fire. As a hydrologist and person that helps to evaluate impacts to the stream systems and riparian areas, we're out here as a hydrologist. I'm specifically trying to help with that a lot of times, and so we're trying to direct these resources to perform tactics that are least impactful, and so when they're making a decision to put a control line across a riparian area or a drainage, we're trying to get them to put it in good locations. The direction that they want to cross the drainages is important, because our riparian areas are probably a very limited resource on our field office, and so protecting those is pretty important. are concerned about infestation of damaging weeds post-fire after putting a blade through or using a dozer through some of those areas, and so trying to minimize that actual disturbance of the organic layer that is the topsoil that really grows well in there. Disrupting flows in those channels is pretty important because these banks are highly erosive and can be easily altered. And so, what we try to do is, they'll give us information about where they want to put the line, and then, we go out and we scout that and try to provide input on how they can change those, in short time frames. We identify, with information that we have prior to the fire, where our areas are that are most important, and we provide that information through maps and that sort of thing. Water quality is a big issue too. The increased sediment that's going to be caused by this, we don't want to cause to be higher if we can, and so trying to avoid the riparian areas is our first tactic. Again, direction and where we put that line through riparian area is important. And again, the objective for our protecting our riparian areas is avoidance, and you're probably going to get tired of me saying that, but it really is the most effective. But oftentimes, besides heavy equipment or mechanical equipment on the ground, we're fighting these fires with aerial resources such as helicopters and fixed wing airplanes, and they're using retardant and bucket drops. And so specific to Grand Junction and a lot of other field offices, there's guidance in our resource management plans on distances from riparian areas that we'd like to see retardant drops occur. And so we often inform the firefighting decision makers of these locations we would like to have retardant avoidance areas, and not use retardant in those areas, or even water from other sources into different drainages. Sometimes that occurs where we don't want somebody picking up a bucket of water and one drainage over into another because of the fish habitat or some special species of wildlife or fauna we have in there. And so they generally try to keep retardant drops out of the drainages in as far as ways they can. But when they do occur, often what we do is mostly just do a report of occurrence and document that occurrence when it happens. And there's a national database that goes into, and the folks that manage that database then kind of take a look at how often that's occurring. But retardant is, it's full of phosphorus, so it's in systems such as ours that are phosphor limited. It can cause some post-fire water quality impacts, and but we just try to avoid putting retardant there. So during the suppression repair activities, the resource advisors, we go out there and we try to help return the disturbances back to as close as the original condition as possible, and that occurs in the uplands as well as in the riparian areas. One of the things that we look at in the riparian areas when they do happen to disturb those areas, or drive across the stream, or put a dozer line across the stream, whether it be light or pretty heavy-handed, one of the things that we really try to do is, again, put it back to an existing condition. And one of the easiest ways that I've found to do that in situ, working with an equipment operator who is normally just is not just a construction worker, but somebody who normally just does construction or is out there doing big earth moving projects. These guys are out there in their normal jobs just getting paid to move dirt, right? Not put dirt back. So what I have these folks do, what I try to do is I try to get them out of their piece of equipment. I walk them up and down and just have them take a look at that riparian area and that channel shape and what's there, above and below their disturbance, and tell them that's what I want to see, after they get done doing that work. And what I'm really looking for is main channel shape. In a good intermittent or perennial stream, you can see a defined bed and bank, and you can see floodplain features. You can see the shapes of those outer terrace walls, and so that's what we request them to do, is just try to put it back to that shape as much as possible. If we have instances where they've removed larger clumps of the matting or the sod, we try to get them to place that back into position that it previously was. But at the end of the day, we try to get it to look as close to what it did prior to the activity. And what we're finding in what's been more common these days is trying to get specific pieces of equipment, specifically track hose, excavators that have arms that have thumbs on them so they can pick up stuff and do a little bit more fine detailed work for us, rather than just using the dozers that probably put the line in to start with. That being said, dozers can be successful, and we're not trying to spend a bunch more money, fixing things or making it look landscaped, but those excavators are really more successful at that suppression, repair, and rehabilitation effort than going back with those larger pieces of equipment like dozers and graders. So, but really it's about trying to make it as close to what it is prior to that disturbance. We probably wouldn't concentrate on doing any kind of shrub or tree planting, because hopefully the disturbance was minimized prior to that, or avoided removing some of those trees. So oftentimes we don't do larger plantings, but sometimes seeding will help to protect those banks for us.
During the fire.
Yeah, and so the tactics we'd like to see in those riparian areas is, number one, avoidance. But if we can't, then the next thing we really try to do is get those folks to lift that blade as much as they can to just remove what is absolutely necessary. And I think as a resource advisor, that's pretty important job for you to help those operators understand is, when you're going through there, lift that blade so you're just barely scalping that combustible vegetation and not taking that really important soil surface, and that's important for regrowth after the event. So in the post-fire assessment process that we went through, BAER, the burned area emergency response action, is there's two steps or two phases in that process, and BAER itself is really about emergency stabilization. We're worried about the very first precipitation event that could cause impacts to values at risks. And so that's called ES, emergency stabilization, and that's the first year after the fire. And so that BAER assessment is really to evaluate that need to help protect values at risk. And so funding that's available for that comes from the same funding that fire suppression uses. So there's I'm not going to say an unlimited amount, but there's kind of an open account there that can be used to spend money for that emergency 1 year post-fire stabilization impacts. And it's not competitive, and so that's why it's important for us to get in here quick to really ascertain what's needed in that first year, or even before that first precipitation event, because this was kind of an end of the year fire. If this had happened in June, we'd have been worried about that monsoonal moisture coming in August. That would have been the storm we're worried about. And so that's kind of the storms we're worried about now, is we need to get this stabilization done before those first storms. So outside of the ES, or the emergency stabilization time period, we have the BAER, the burned area rehabilitation process. And in BLM, that plan, those two, ES and BAER, there's another term for it, it's called ES and R, Emergency Stabilization and Rehabilitation. BLM kind of puts both of those together. Other agencies do ES and BAER separately, but the BAER can do just an ES plan or a BAER plan, or sometimes they put them both together for places. And so we developed an ES and BAER plan for the Pine Gulch Fire, and that BAER plan is 4 years, 3 years of additional funding, and that funding is competitive. So what we decide to do for the long-term stabilization, we have to put into a plan and submit to the agency, and the agency administrators then decide how much funding we get. And so we can request, you know, however much money we think we need, but then at the end of the day, you know, we could get some of it or all of it or none of it, depending on how many other fires across the nation are burning. And this year, California, Oregon, and Washington, all, you know, tons of other BLM fires across the nation had occurred, and so that BAER funding is going to be pretty competitive.
In the grand scheme of things, we'd like to seed more than we can, but feasibility always is in play. Since this was almost 140,000 acres, we obviously couldn't reseed all of it. And after we had done our on-the-ground monitoring with the BAER team, we realized that the severity wasn't as bad as we thought. So a lot of these ecosystems have evolved with fire, especially the oak brush communities. A lot of them were already resprouting, so some of the higher elevations get a little bit more moisture, and those are probably going to come back a little bit easier without help from, you know, an outside resource like seeding. The areas that were a little bit lower in elevation, we looked at those, especially some of them have a lot of cheatgrass encroachment. The land health data that we had collected prior may have not been as bad. The land health data that we collected prior helped determine kind of those areas. So using all these criteria, our ecologists kind of plugged in to our GIS, elevation, slope, historic land health data, and just vegetation type. And with that, we were able to come up with some polygons for priority areas to reseed. And as Kevin touched on, since this year is competitive with money, it's also been really competitive with the seed sources. So we have a warehouse that we go out of, the BLM, but we're competing with other states and other fires for that. So we had to really kind of tweak our seed mix. But ultimately, we're seeding the areas that need help with stabilization of the soil and trying to get some of those natives to come back a little bit better.
You know, it's pretty well known that, you know, post-fire erosion increases and changes in hydrology are expected, but along with that normal vegetation that was here, one of the things that also really is detrimental in this fire is the steep slopes that this fire burnt in. Over 65% of the fire was on slopes greater than 35%, so that just adds to what's going to happen, you know, with the next round of moisture that comes in here.
We're only seeding the areas that are flatter just because the chance of the success is a lot greater. So the best way to do that is to aerial seed that, so using airplanes, and on some of the dozer lines they're using helicopters to lay down that seed. We try to, as much as we can, seed in the winter, hoping for snow to help kind of solidify that and kind of get the seed to soil contact, and then also give it a little bit of a jump start with the moisture.
The Grand Junction Field Office has had a really successful aquatic inventorying and monitoring program, AIM program, and which is a national effort to go out and assess the health of the BLM lands. And so we're going to continue with the AIM monitoring in our plots that we've had. We'll probably establish a few new places.
And it's usually a crew of 3 that comes out, and they do, you know, soil pit and kind of try to texture out the soils and take photos, and they do line point intercept and species richness, things like that, to just give us a better idea of what's really out there. And so we asked for funding for the next 4 years to have a crew come out and go to locations spread out all throughout the fire and just kind of see what different parts of the Pine Gulch Fire look like, how the seeding's giving us a better idea, you know, if there was seeding there, how that seeding is going. And I do anticipate us adding targeted points onto the Pine Gulch Fire burn area just so we can capture how the seeding is doing and things like that.
We also have an aquatic assessment, inventory, and monitoring program where we go out and do protocols in the stream to monitor fire. And we have a lot of that information prior to this fire, and so we'll continue with that effort. In addition, we've had a lot of universities and other organizations reach out to us wanting to gather information about the effects of this fire into the Colorado River. So we're going to be doing a few other things in the fire to, you know, kind of look at hill slope type monitoring efforts to see how things are really reacting.
Historically, we have a lot of data in this area. We've been treating weeds out here for many years, and you know, some of the main weeds that we were looking at was like Russian knapweed and white top and hound's tongue in the higher elevation. And we did receive money, and so we're hoping to have a weeds crew out next spring, and they're going to start surveying the areas, you know, mostly along roads and where the dozer lines were put in. That's kind of our highest priority, and from there they'll start treating. And so we just are going to try to get a start on that before they take over and hopefully give the seed a chance to take over.
We come out here after the fire or work on the fire that's quiet and do what we call suppression repair, and that's help guide resources in repairing the damage that occurred through suppression activities. And then post, kind of after that step, a lot of times, or what can occur is that BAER team, or that burned area emergency response team, can be requested. And there's a National Department of Interior, DI BAER team coordination program. They come in and evaluate whether a BAER response is needed. And it was determined that a BAER response was needed here because of, one, the lack of folks to help in a BAER assessment. We just didn't have the personnel out in the field office to provide that BAER assessment methodologies and staffing. We had staff out on this fire for up to 45 days, and so we were just running out of people. So that was one of the criteria. We had some values at risk that were pretty important, and so those values at risk needed to be evaluated by folks to help really ascertain the level of threat to those. But what that BAER team does is it comes in here and it really takes a look at how the fire burned. And there's a couple things that we do to evaluate that. First, we look at the vegetation severity, burn severity, and that's how much of the vegetation on the landscape is consumed in this fire. And we look at that through aerial imagery, and they classify that to tell us, categorize that burn severity into low, medium, and high burn severities, and then, or unburned within the fire perimeter. But then what we do is we go out and we take that information and we look at the soils to develop a soil burn severity map. And the reason we do that is because studies have shown that it's the soil characteristics and how that fire interacted with the soils that really help to inform the changes in soil and erosion and potential issues to values at risk. And so we go out and we go out as in teams, and we actually do field data collection and look at 5 factors in the soil. Some places do a little bit more in-depth things, but we really try to just look at those 5 factors due to time, and those are vegetation, how much of the vegetation was consumed. That's not only the canopy vegetation or the stuff you can see on top of the ground, but that litter and duff layer, that dead material that's sitting on the ground. We look how much of that consumes. We look at the roots in the soils how far into the soils were the roots damaged. So we dig into the soil and take a look at those roots. We look at soil structure. As fires get hotter, the structure of that soil can be altered, and that's pretty important. We look at hydrophobicity, which is water repellency. Will precipitation that falls on land be able to soak into the ground? Sometimes you can have natural hydrophobicity due to drought conditions, and I think, and then some soils just have natural hydrophobicity. So we go and look at what the natural conditions should be and compare that to what the post-fire conditions are, and try to ascertain what those conditions are. And the other one we look at is ash color. Ash color and depth help us determine how bad the soils were affected. And we take all that information and we put it through some models to help evaluate how much increase in soil and erosion that we are going to have on this fire. The lucky thing that we had with this fire is I think it burned so hot and so fast that the residence time on the land itself was short-lived, and so we didn't have a lot of heating of that soils. You know, early on in the fire we were able to go look at some of the colder areas, and we were finding very low soil burn severity in places where it looked like the vegetation had just been removed quite heavily, and we were seeing green grass and things growing back, you know, before the fire was even out. So that was all good news. We expect that because of that low soil burn severity, you know, recovery should be on track with what it normally should be. But again, the steep slopes and the highly erosive soils is still pretty important there. And then, you know, we take that information and put it into a report that is provided to the field office to help determine on how we want to do post-fire rehab. Seeding is probably one of the things that is going to be the most effective for our area because of the flat areas that you can see behind us. We'll take the seed pretty well. We won't do anything on real steep slopes, other than there might be some post-fire data collection for university studies or USGS studies that we'll be proposing to do out there. And then there's all the infrastructure rehabilitation that we're going to have to take care of. You know, we burn up a lot of fences, we burn up a lot of road signs and trail signs. There's some road infrastructure that we'll deal with, but for the most part, I think a lot of our BLM primitive road systems are just going to need some maintenance and some post-fire storm patrols to help manage and you know, clean it up after the events occur, because it's cheaper to do that than to try to spend hundreds of thousands of dollars of seed or mulch out on this landscape, because it's just ineffective and that sort of thing. But again, this fire is you know, the biggest thing this field office has ever seen, and you know, there's a lot of work to come, and you know, we'll probably be surprised by some things that happen, and but we'll all try to learn from it and pass that on to whoever needs it.